Hello and welcome to Algebra 1, Chapter 4.7, and today we're going to discuss parallel and perpendicular lines, and most importantly, from the algebra aspect, we're going to talk about writing equations for those lines. So we're going to start out with parallel lines, and so I'm assuming you know what parallel lines look like when they're graphed, right? They're gonna never touch, never intersect. But again, from the algebra aspect, we're going to be concerned about writing equations for them, and our main thing is they have the same slope. And so if you look at these three lines, do you know what the slope of these three lines is? These lines have a slope of 1. Here we have 1x, 1x, and 1x. Okay, so each of these lines goes up 1 over 1, and that way they will never intersect if they have that same rate of change. So we want to write the slope-intercept form for an equation of a line that's going to pass through this point and is parallel to this line. Okay, so what this second half says, parallel to this line, that is telling you your slope. Okay, what is the slope of this line? Slope of this line is a half, so guess what the slope of your line is going to be? A half, and it's going to go through that point. And so there's two ways you can do this, we've discussed. You can find B. You have the info to find B, you have an x, a y, and an m. So there's -1 equals 1/2 times 4 plus b. So then we're going to have 2 plus b. So there's -3 equals b. Final answer then would be y equals 1/2 x minus 3. Okay, there's one way to do it, and you don't have to do it both ways, but you can definitely pick a way that makes more sense to you. The other way is, since I have a point and a slope, you could do point slope form. Okay, remember point slope form, and then you want to rearrange it because it specifically asks you for slope intercept. But this is one reason we practiced rearranging in the last, 2 sections ago now, I guess. Y plus 1, because it's minus a -1, right? Y plus 1 equals 1/2 times x minus 4, and then you're going to distribute the 1/2, which is going to be 1/2 x minus 2, and then we're going to subtract the 1. Now, like I said, you don't have to do it both ways, but you might pick the way that makes more sense to you. So let's try that again. This time I was to say, write the point slope form, okay, of an equation that passes through this point and is parallel to this line. So again, this last part, parallel to this line, is telling you the slope. So what's our slope? Our slope is 1/4. Our point is 4, -1. And we are going to plug those things into point slope form, which we're going to hope you have memorized. If not, I suggest you write it down a bunch of times. Alright, so it looks like y plus 1, because that's minus a negative, equals 4 times x, except I was wrong there. It's not 4, it's 1/4. 1/4 times x minus 4. And you're done, because remember, that is point slope form. You don't do anything else to point slope form. Okay, so the next thing we need to talk about is perpendicular lines. And so perpendicular lines, the standard formal definition is lines whose slopes have a product of -1. Okay, so we could look at it as to say, okay, well, 3/4 times what is -1? Okay, well, to make the 4 cancel, we have to have a 4 on top. To make the 3 cancel, we have to have a 3 on the bottom. And to make a negative, it has to be negative. Now, I have a slightly easier way to remember what in the world is this. It is the opposite reciprocal. Okay, that's what I have up there. Their slopes are opposite reciprocals. So opposite refers to the sign. Notice the 3/4 was positive, and so we had to make the 4/3 negative. And then you know that reciprocal is that you're going to flip your fraction. So if you look over here at these slopes for these blue lines, a negative 1/2, a positive 2/1, and then horizontal, which has a slope of 0, and vertical, which has a slope of undefined, they obviously make perpendicular lines. Do remember, there is never a no slope. No slope does not exist. So we have a trapezoid, and the height of the trapezoid is measured on a segment that is perpendicular to the base, to either base. This would be a base, and this would be a base. Okay. In trapezoid ARTP, which is the big trapezoid, we actually have two of them here. ARTP, the big trapezoid, AP and RT are the bases. So those are those two that I highlighted first. Can EZ be used to measure the height of the trapezoid? Alright. It might be obvious why not, okay, but let's actually find some numbers to be a little more concrete here. So we said to be perpendicular, the slopes have to be opposite reciprocals. So let's find the slope of RT, and let's just count it. So from R, we're going to go up 1, 2, 3, 4, and we're going to go over 1, 2, 3, 4. Look at that. So that's a slope of 1. And if we look at AP, that should have the same slope, right? Up 1 over 1, up 1 over 1. Okay, that has a slope of 1. And so then let's look at the slope of EZ. So starting at Z, no, we'll start at E. We're going to go over 1, but I'm not going to go over first. Yes, I do know how to count slope. Hold on. Always rise over run. Let me try that again. Okay. We're going to come down 1, 2, 3, 4, 5, 6, 7. We're going to come down 7 and then go over 1. So the slope there is -7. Is 1 and -7, are 1 and -7 opposite reciprocals? No, they're not. So can EZ be used to measure the height of the trapezoid? No, because it is not perpendicular to the bases. And even though it looks like it, remember things are not always drawn to scale, and you should definitely do the math. Okay, so let's write an equation in slope-intercept form of a line that passes through this point and is perpendicular to this line. Okay, so perpendicular to this line tells us the slope. But in this case, do you know what the slope of this line is? You do not in its current state. So what we need to do first is you need to put this into slope-intercept form, because that's the only way you're going to get its slope. Alright, so let's see here. I subtracted 7x over. I'm dividing by -2. Remember, it is a -2y. Positive 7/2 x minus 3/2. Okay, so what's the slope of this line? This line has a slope of 7/2. For us to be perpendicular to it, and I'm going to use this upside down T, means perpendicular, and this was just tells me that this is my perpendicular slope and not my regular slope. So what is the opposite reciprocal of 7/2? -2/7. Okay, there's my slope, there's my point, and then you need to decide, do you want to use slope-intercept form and just find B, or do you want to use point slope and rearrange it? I think I'm going to do point slope and rearrange it. So I'm going to write out point slope. By the way, you can use either one. They should get the same answer in the end. So this is going to look like y plus 1 equals negative 2/7 times x minus 4. So y plus 1 equals negative 2/7 x plus 8/7. And I'm going to subtract 1 from both sides. And I'm going to get y equals negative 2/7 x plus 1/7. There we go. Alright, so let's try that again. Still writing point slope form, passing through this point, perpendicular to this line. So this part right here tells us a what? It tells us a slope. And in this case, do we already know the slope of this line? We do. This one is in slope-intercept form, so the slope of this line is 2/3. So what is my perpendicular slope? Negative 3/2. Alright, so I have a point, I have a slope. Do you want to do point, slope, and rearrange, or slope-intercept and find B? Okay, let's do slope-intercept and find B just to shake it up a little bit. So 7 equals negative 3/2 times 4 plus B. This is 7 equals negative 6 plus B. Remember, you can cancel before you multiply your fractions. This is why we work with fractions. Alright, I got B equals 13. So we get y equals negative 3/2 x plus 13. There we go. One more example. Okay, slope-intercept form of the line that is perpendicular to 2y plus 5x equals 2, and it passes through this point. Well, hey, what is 0, 6? 0, 6 is a y-intercept. That's already telling us our b. This will give us our m, but what do we need to do to it first? We need to put it into slope-intercept form because that's how you get your m. So we're going to subtract 5x from both sides. You're going to put your 5x in the front. Divide by 2. So y equals negative 5/2 x plus 1. So the slope of this line is negative 5/2. What is my perpendicular slope? Positive 2/5. So then I have y equals mx plus b, and I didn't have to find my b because this time it gave it to me. Alright, that is for 7. Remember, we're not concerned about what parallel and perpendicular lines look like on a graph. We're concerned about their slopes so that we can write the equations of the lines. Let me know if you have any questions. Feel free to post them on the blog or come in before school and let me know. We'll see you later.